Hello everyone, I am Kailash Prasad, a PhD scholar from IIT Gandhinagar. Welcome to live session 3 of Digital Circuit. We'll be having this live session every Tuesday, as already informed, from 6 p.m. to 7 p.m. The main motto of this live session is to solve some questions on the topic, whatever taught in the NPTEL lecture, and I'm here to solve all of your doubts if you have any. So, we will start with the session. I hope my screen is visible. Can anybody confirm that?
Yes, sir.
Thank you. Okay, so this is the course layout. We have started with the introduction in the number system, and then we have seen Boolean algebra, and in the last session, we have also solved some of the questions on combinational function minimization using K-map and Boolean identities. In this week, our major focus will be on the logic gates, and we'll be solving at least 6 7 questions on logic gates, and we will try to understand how to solve complex questions on logic gates. This session will also help you in doing the assignments on the assignment 3 and assignment 4. So before proceeding further, I have just intentionally put this picture here just to motivate you guys about the digital electronics, the domain of semiconductors, and the domain of VLSI, what we call. Right, this is one of the latest NVIDIA chip. It is called NVIDIA Grace. Right, it is one of the first CPU to use one of the fastest memory which is available, which is in the form of DDR5. It follows that protocol. We don't want to go into that detail, but the main question is, what is it made up of, right? So it is made up of transistors, what we say, right? But when we design a digital chip, right, the basic unit are actually not transistor, rather it is standard cells, and standard cells are nothing but logic gates, right? So we have various logic gates available with us, and we design our circuit in the form of logic gates, right? And that is the reason why I have put this particular chip here. And you might be seeing all the chips like the NVIDIA Titan, right? The Ryzen recent processors, right? And every device do we have right now, right? It contains some form of electronic chip in it, right? And in the future, when you will take up this domain as your profession, right, you will understand the designing of this chip, and then you will appreciate, right, the knowledge of logic gates and how this logic gates will help you to design such a complex chip. Each of these chips will contain millions and billions of logic gates. Okay, so let's start with the very first question which we have, and please note that this is one of the basic circuit which can be available in the semiconductor, in the VLSI, right? And this circuit, anybody knows what this circuit is called? Anyone?
Not get IC.
Not yet, I see. Okay. Anybody else? Someone is saying that it is called as not gate IC. Okay. So it is not that inverter. Okay. So yeah, individual gates are inverter. However, this circuit is famously known as ring oscillator. Okay. So this is one of the very basic circuit which is available in the digital design, right? And this circuit is being actually used to benchmark your new technology. Everybody hears about this 5 nanometer, 3 nanometer, okay, 10 nanometer, right? So any new technology which comes, the very first circuit that has been made using that to benchmark digital circuit is this ring oscillator, right? Now the question is, right, uh, I think the question here is what this circuit actually denotes, right? And what will be the answer out of 4? Can anybody want to answer that? What this circuit will do? We have 4 options, okay? An oscillating circuit with its output as a square wave, right? The second is the one whose output remains at 1, right? Third is the one whose output remains at 0, and the fourth is it has a single pulse but three times the propagation delay. Anybody want to answer that? Anyone? You can comment on the chat box if you want. Okay, 1A. I have two answer, three answer, all one, four answers. Okay, so yeah, I think I have already given you a hint, right? Calling it as a ring oscillator, right? So this circuit will be an oscillating. It will generate actually an oscillating signal, which will be a square wave. How does it will work? Is suppose if you have provided any signal, zero, and you have left it. Okay, you have provided and you have left it. It will make it one, then it will make it zero, right? Then it will make it one, right? So then after zero, it will come one. Okay, then it will go, one will go to zero, zero will go to one, then one will go to zero, right? So suppose I have the inverter delay. The inverter delay is t nanosecond, okay, or t unit of time, each of inverter delay. So the delay between input and output will be 3t, okay, and the square pulse which will be generated will be like this, okay, it will be like this, it will be like individual component, right? Individual cycle will be 3t. This will be 3t. This will be 3t. Okay. So this is how this circuit actually works. Okay. So all the other options are incorrect, right? The first option is correct. Okay. So you should remember this circuit. Okay. It's a very basic circuit and everybody should know about it. Any doubt in the working of the circuit and why the answer is A and 1? No. Okay. Vikramaditya, yeah, he is quick to respond. What about other students? I believe there is no doubt. So I will move to second question. Okay. So this is a very interesting question. There are five gates which is being used in this diagram, right? And one, two, three, four, five. And the question is which of this gate is redundant? Redundant means it's of no use. Anybody want to answer this? Please try it out. You have 1 minute. Sejal Jain, how to time period cycle is 3t in square wave? Okay. Uh, Let me first clear that, and I will come back again. Okay. So see the inverter delay I have taken as t, right? So how much time the zero will remain zero? Okay. So it will remain zero. We have zero here, right? Till this one is being till this one is being propagated. Till this one is being propagated over here. Okay. How much time will it take? It will take t. It will take 3t time, right? So zero will remain zero for 3t time, and one will remain one for 3t time, right? So time period is not 3t, time period is actually 6t. Okay. So that's how so each of these inverter delay you can take unit time, and on the basis of that you can calculate what is the I was talking that 3t will be the time till the 0 remains 0 or 1 remains 1. Is that clear? Is that clear? Okay. Any more questions on this? I hope not. So I will go to the second part. The question was, uh, which of the following gate is redundant? Redundant means that it is of no use. Even if I remove that particular gate, right, it won't change my circuit. The circuit output will still remain the same. Anybody wants to answer that? Which gate, if I remove, it will still remain the same. The circuit will still remain the same. Anyone? Okay, then I will proceed. See, 5 is not in the option, so obviously 5 is not the gate. Okay, so let us see what is the output of this particular output of each of this node. Okay, so if we see here, this W, right? So the output will be here W bar. Okay, for this node. Okay, and if this you see this W bar is going here. So I have W bar plus. Okay, so what is the input of these two gates? Z plus W bar. Z, sorry, ZW bar. Okay, ZW bar. Then uh, after this, what I will have Z bar XY. So Z bar XY. Right? I hope my expression is correct. Okay, but if you will simplify it, you will see that I can take W bar common. Right? This will be 1 plus Z. Okay, so it will remain as W bar. Okay, so the final expression is W bar plus Z bar. Okay, this is the final expression W bar plus Z bar XY. So this is Z. Okay, don't confuse it with 2. This is Z, right? So it means this particular component, right, is actually being dissolved, right? So it has been removed. So whichever gate is generating this is redundant, right? So the answer is 2, right? So this 2 which is generating W Z W bar. Okay, even if you remove it, what will be the final answer? The final answer will be W bar, and here Z bar XY, right? So W bar Z bar XY. Okay, so the answer is gate number 2. Any questions? How to solve this problem? Any doubt if you have not understood? No questions?
Sir, can you repeat the concept of redundant?
Okay. The concept is redundancy. Okay. So the question here says that which of this gate is redundant. Okay. So why this question is actually important, I will just tell you. One minute. Yeah. Right. So suppose when you design a very large circuit, okay. So very many a time you just focus on functionality, right? Whether your functionality is correct or not, right? You actually don't focus on how much gates you are using and what is the area of each of these gate, right? So the one of the goal of design is the functionality. Obviously you want your circuit to work correctly, whatever circuit you design, but other goal is it should take minimum number of gates, or it should be minimum area, right? So this is one of the very important concepts in the semiconductor industry, in the digital design. Okay, and that is the reason why this question has been asked, that okay, you see this circuit and the question is, even if I remove uh, any one of these gate, right, the circuit output will should still remain the same. Okay, so that gate is called redundant gate, right? So it doesn't matter even if that circuit is there or not there. Okay, and that is the concept of redundancy, or that is what redundant mean. And how to solve this problem, right? So what you do, you just write down the expression of this particular circuit. So suppose this is Y, right? Not Y, Y is already being used. This is P. Okay, if I write the expression of P will be W bar, right? So W bar will come from this part, right? From the second gate it will be plus uh, W bar Z, right? Then plus Z bar X and Y, right? So Z bar X Y, right? So this is an OR gate, right? And these are two. Now, if I simplify this circuit, or this expression, what happens is I can take W bar common. I can write 1 plus Z, then plus Z bar X Y, right? And I can write, because 1 plus anything is 1. Okay, so this we have already discussed in the last session, and it has already been discussed in the class, that you can reduce it to 1, right? Okay, odd with 1 it is 1, right? So the expression will be Z bar XY. Okay, you cannot further reduce it, right? So this is the minimum expression you can get. Now the question is, this expression you are getting, it means if you compare this part, and if you compare this part, this particular part and this one, right? So the first term remains, the third term remains, the second term has been removed. Okay, it means we don't require the second term actually. You don't require that. Okay. Now the question is which gate is generating this second term, or which are the combination of gate that is generating this second term. If I see, this is W bar and Z. Okay. So if I remove this gate, if I remove this gate, circuit, which will look like this. So this is my Z, and then sorry. Hmm. So which will look like this. Okay, Z X Y, and the output of the circuit will still remain W bar plus Z bar X Y. Right. So this is what we call as redundant gate. Okay. So there is nothing a concept called redundant. Redundant is a term which means if you remove that particular gate, it doesn't matter, right? The circuit will still work correctly. Is that clear?
Yes, sir. Thank you.
Other students, any doubt?
No, sir.
Let's move to the third question. Okay. So this is a circuit, and okay. So there is an error in the question. It should be C bar and D bar. Okay. So my circuit, the output is B plus C bar D bar. Okay. Now you have to tell me that what will be G1 and G2. Anybody wants to answer that? If your Y is AB plus C bar D bar, what will be G1 and G2? Which gate it will be? Which two pair of gate it will be?
Yes, so not
What
G1,
you are saying?
G1 for not.
Nor and all. You are saying this part?
Yes, sir.
Okay. So I have one answer which says one. Prajakta is also saying one. What about others? Please respond. What about others? Are you in confusion? Okay, Vikramaditya is saying one, Lavri one. Okay, so I have four votes on one, right? No votes on any other option. And let me see which of this option is correct. Okay, so those who are not understanding, just see how to approach this particular. So what do you want? AB Asha is also saying one. Okay, thank you everyone. So the expression is AB plus C bar D bar. Okay, so let's see what we are getting here is CD. So this is an OR gate. Okay, so this is an OR gate. So here you will get C bar plus, sorry, C plus D bar. Okay, and if you apply De Morgan's, right, so it will be C bar dot D bar, right? So one of the expression you are getting directly, right? So it means you have to do something to take AB here, right? If I can get AB here, this can be an OR gate. Okay, this can be an OR gate, because you will directly add AB plus C bar D1. Right? That's easy. Okay, so assuming that this is an OR gate, okay, let's see if I can get AB here or not, right? And by using which gate you can get AB here. Okay, so I have two options, 1 and 3, in which G2 is an OR gate, right? So okay, Sejal is saying that 3 is the option. Let's see. So if I see here, so this is A bar, this is B bar. Okay, A bar and B bar. And what I want is AB from A bar and B bar. Okay, so if you apply A bar plus B bar to D bar, right? So the answer will be A bar bar dot B bar bar. Okay, so this will be nothing but AB. Okay, so it means that this is a NOR gate. Okay, so this is a NOR gate, this is a NOR gate, and this is an OR gate. Okay, so the answer is the first option. So I hope this is clear to everybody? It is.
Yes, sir. Yes.
So what we will do is we will proceed to next question then. Okay. So very interesting question. Uh, the question is, which of the following gate is an universal gate? Okay, so you have to tell me that which of the gate is universal gate, right? So before that, universal gate is a gate which can be used to design any other gate. Okay, so we have couple of universal gate. Can anybody name it? Which are the gates which are universal?
NAND and NOR.
Nine nine and honor.
And is the answer I'm getting from everyone, right? Uh, do we have any other gate apart from NAND and NOR which are universal? XOR.
And gate,
Sorry,
and gate,
NAND is not a universal gate. You can use XOR and XNOR also, right, as a universal gate. Is it correct or not? So this you have to tell me, right? But before that, uh, what- here I have two options. Sorry, three options. Okay, A, B, and C. The first one is an OR gate. The second one is an AND gate, and third one is something X bar Y, right? And if you search in literature, it is called as inhibition gate. Inhibition gate, right? Can anybody tell me which one of these is a universal gate, or answer is four? None of the above.
Four.
Four, sir. Four. Four.
Everybody
Four.
agrees
Four.
with that?
Yes.
Okay, let us see. Let us see. Right. So everybody knows that x plus y and x dot y is not a universal gate, right? But I'm concerned about this x bar plus y. Okay. So let me try something with this particular gate, right? And just by using this gate, if I can make NAND or NOR, right, it can be universal gate. And if I'm unable to make it, right, it means that it is not a universal gate. Okay. So just make this gate as like this. Okay, a box, right? So it's a new gate. Okay, and it has output z, right? And I'm giving two input, x and y, right? And if I put y equal to 0, y equal to 0, okay, so the output will be what? Output will be x bar, right? So output will be x bar. It means it will behave as a not gate. Not gate, right? If you fix y equal to 0, and if you provide x here, the output will be x bar. Everybody agrees with that, right? Right.
Yes, sir.
See, now what I want to do is let me see if I can generate this or not, x plus y bar, something like that, right? Or not this one. If I go with this one, x dot y to the whole bar, this will be what? X bar plus, okay, x bar plus y bar. What I am trying to do is to generate this one. Okay, so let me design a circuit for you. Let me design a circuit for you. Let me see if that works or not. Okay, so I design a circuit like this. Okay, and I put x here. Okay, and then I put, so this the second input, what I am giving here will be like this. Okay, so let's see if this is 0, this is y, right? So can anybody tell me what will be the output of this gate? Please note that this is the inhibition gate, this one. So let's see, right, what will be the output. So here it will be y bar, right? Everybody agrees, right? And the output will be x bar plus y bar, right? Is it correct, everybody?
Yes, correct, sir.
Yes, sir.
What I have done is I have generated a NAND gate using only this inhibition gate, right? And if I generate a NAND gate, if I can generate a NAND gate without using any other gate using this particular circuit, I can generate any circuit, right? Because you agree that NAND gate is a unique, right? So the answer will be 3 instead of none of the above. I hope everybody agrees with me, right? So this is a trick question, and please make sure that you understand this concept. Everybody agrees with the answer. Everybody understood the answer.
Yes.
Yes, sir.
Yes, sir.
Sir.
So I think this was asked in one of the gate question. Okay, so gate 2015 or 2014 question it is, right? So this question can be asked in any competitive exam, or in your assignments also. Okay, so let's move to the next question. This one, right? Now anybody wants to answer? What will the output of this combinational circuit? So you do along with me, okay? And if you get to the answer, please respond in the chat. Okay, so I will also try to solve. If you see here, this node will be AB. Now this node will be BC. Okay, this will be AB into BC. No, sorry, ABC. Okay, this will be ABC, right? And this will be AB XOR BC. Okay, and this will be AB XOR BC XOR ABC, right? Everybody agrees? Now, what we have to do is we have to simplify in either of one of this expression. And the best way to simplify it is you just make a truth table, okay? So I will also do that. That's the easiest way to approach this question. And what I will do is I will make a truth table for ABC. Okay, so A, B, and C. And just follow with me. Okay, so I won't directly make the truth table of the entire expression y, rather I will make first for AB. Okay, so AB will be 0 0, then 0 0. Okay, and then it will be again 0 0, then 1 1. Okay, then I will make for BC. Okay, so this will be 0 0, then 1. Okay, then again 0 0 0, and 1. Okay, then if you will see ABC, so ABC, so all zeros, because there will be one zero in any one of the term, right? And here it is 1. Okay, so now you get AB. So you name these terms as your X. Okay, so P, Q, and R, right? Now what you have to do is you have to take the XOR of P, Q, and R. Okay, so if you take the XOR of P, Q, and R, so XOR is what? Anybody know? XOR is nothing but an odd one detector. Okay, so if you take the XOR of three numbers, if there is odd number of one, it will give out. Or you can simply apply the XOR formula also, right? So it will be 0 here, 0 here, it will be 0 here, it will be 1, then 0, then 0, right? Here it will be 1, right? Here it will be 1. Okay, so this is the term which we have. Okay, apart from that, these two terms we have. Okay, so if I write the equation for it, it will be a bar bc plus abc bar plus abc. Okay, and you can simplify it to a bar bc plus ab, right? Because c plus c bar will be 1. Okay, and then so this will be your a bar bc plus a b. This you can write b a plus a bar c. Okay, and I don't have space here, so I will write somewhere else. Okay, so just give me a minute. Okay. So you have b plus a bar c, and you can write it simply, right? So you can write a plus a bar and a plus c. Okay, so a plus a bar will be 1. So this will be b a plus c. Right? So this will be the third option. Everybody is fine with this approach?
Yes, sir.
Anyone has any question? How I have approached it? It I have broken down in a very simple manner. Okay, what I've done, I have written the equation, right? But for me, it's a very complex equation. I cannot directly solve it. So what I have done, I have made a truth table, and then I have made a truth table of individual component, and I've written it P, Q, and R. Okay, and I know the XOR of P, Q, and R. Okay, and then you made in this particular form. This was very easy, right? And then you have made a truth table, right, which represents like this, right? And then you have written the equation directly, right, and solved it, and you got the answer, right? In 2 minutes, not more than that. Is it fine with everyone, or should I repeat?
Fine.
It is clear. Okay. What about other students?
Clear, sir.
Well ahead. So this is the question. The output y will be. Anybody wants to answer that? Right. So this I won't solve. I will wait for 2 minutes. Everybody, please solve this question, and please let me know if you are able to answer this question. 'Anybody got to the answer? 3. Okay. I have one answer from Lovely Verma. The answer is 3 from Lovely. What about others? You have one more minute. Okay, so let me solve the problem for you. Okay, so it is very simple. What you have to do, you have to just write down AB bar. Okay, sorry, not AB bar. 1 minute. So A XOR B bar. Okay, this is A XOR B. Okay, this is C bar XOR D bar. Okay, and then this is C bar D. C bar XOR D. Okay, C bar XOR D. Okay. And then you have to take XOR of each and every one. Okay, so let me write the full equation for you. So this is A XOR B bar XOR A XOR B XOR C bar XOR D bar XOR again C bar XOR D. Okay, so what I will do to quickly solve this problem in 1 minute, I will just come rearrange it such that all A's are with themselves. Okay, A XOR A. So I have 2. Vikramaditya is saying that the answer is 2. Let's see. Okay, so A XOR A, then plus B bar XOR B. Okay, plus C bar XOR C bar plus D XOR D bar. Okay, so A XOR A, right? So if you know the truth table of XOR 0001 1011, the truth table is 0110, right? So if you XOR the same, right? So it will give you answer 0, otherwise it will give you 1. So the answer here will be 1. Sorry, it will be 0. XOR, this will be 1 because B XOR B bar, right? Then C bar XOR C, again 0. Then XOR, uh, this will be 1. Okay, then what you will do, you combine these two XOR. Okay, so 0 XOR 1 will be 1, right? Again 0 XOR 1 will be 1, so 1 XOR 1, and 1 XOR 1 will be 0, right? So the answer is 2. I think 2 of the students have given the answer. Vikramaditya and Asha Rani, good job. uh, but this is how we approach this question. Very simple. Any questions? What about others? I believe we have 37 students in the class, but only 2 or 3 are responding.
Yes, sir.
Okay, so if you don't have any question, then I will move to the last question of this session, because you guys are not asking the question, so session is ending very early. It should not be like that. Okay, uh, this is a there are 4 circuits. Okay, and you have to tell me that which of this gate is a NOT gate. Okay, anybody wants to try? So I will name it A, B, C, and D. Okay, so which of this circuit is a NOT gate? Option D. Sai Kiran saying that option D. D. Okay, 3 answers on option D, 4 answers.
Option B.
Option
Option B, sir.
Okay. What about others? D. Okay. Okay. Take it. So, so let me make this question interesting to you. That what I want. Okay. So I agree that option D is can be one of the answer. Okay. But before that, I want you to give me the answer of each of this gate. Okay, so for the first gate, what will be the answer? You have 4 nodes: A, Y, VDD, and ground. And what will be the answer, or what will be the value of Y for this gate? Anybody wants? It will be a buffer. Okay, somebody is saying that it will be a buffer. Okay, so those who know buffer, that is fine. Those who don't know, buffer means if I give input A, then the output will also be A. Okay, anyone else? Okay. Okay, Vivek is also saying it is buffer. Let me see if it is buffer or not. Okay, so if you give A here, so let me first give A as 0, right? If you give A as 0, right, both the transistors, both the transistor will be off. Okay, both the transistors will be off, and Y, you don't know what your Y will be. Okay, so when you are giving, let me first give you one and then see. Okay, when you give it one, right, this will also be on and this will also be one. Okay, so the voltage you will get here, right, if I treat both the transistors as similar in the similar fashion, right, this voltage will be near something VDD by 2, right, and we don't know, right, so I'm just writing this expression nearly to VDD by 2, right, because uh, from top VDD will be coming from ground, from bottom the ground will be coming, the voltage will be something in between, right, so it is in indeterminate range, right, we don't know what is the answer. For us as a digital designer, we don't work in VDD by 2. Okay, but so this is when we provide one, but when we provide zero, both the gates are off, and you actually don't know the answer what y will be. Why? Because to get some logic, either VDD should be connected or ground should be connected, right? You cannot have a floating node. So when both the nodes are disconnected and a node is not being supplied by any of the VDD or ground, this node is known as floating node, or high impedance state, as Sai Kiran is saying, right? It will be in high impedance state, right? So how it will be, the truth table will look like, if there is A and if it is 0, then it will be Z, and if it is 1, it will be VDD by 2, right? Right, and this doesn't make any sense to me, right? So why anybody will use this kind of gate? So there is no definite output of this particular gate, so this is a wrong circuit. Okay? This is a wrong circuit. Everybody clear with the first part?
Yes, sir.
The same thing will happen to the second part. Why? Because both are PMOS, right? And you have provided A again here, right? So in this particular case, if I write Y for the second circuit, so when you will give 0, both the circuit will be on. You will have something called VDD by 2. But when you will give 1 here, both the circuit will be off, and you don't know, right? It will be Z or any high impedance state, right? Okay, and you actually don't know what will be the output. It is a floating node. Okay, right, so second circuit is also wrong. What about the third circuit? Anybody wants to give your opinion on the third circuit? It's interesting, right? Here A is here and Y is on the other side. It's a NAND gate. Okay, Imtiaz is saying that it's a NAND gate. It's a NAND gate. The third one is. What about others? Gate cannot be output. Okay. Sai Kiran, what does it mean? What you are saying? Gate cannot be output. Current flows from source to drain. Yeah, that is fine. Yeah, Sai Kiran, you want to unmute and you want to explain what you are saying? Sai Kiran? Okay, so let me explain. Okay, so what Sai Kiran wants to say, or uh, let me see. So the thing is, Y is connected here. Okay, it is a voltage control device. Okay, so voltage needs to be provided. Okay, okay. So let's see here is Y is connected to the gate of both the transistor. Okay, and for any NMOS or PMOS, for any CMOS logic, right, gate cannot be the output. Gate is always the input. Okay, you provide voltage in the gate. You cannot take output from the gate, right? Because there is no connection between your source to gate or drain to gate. There is no connection. Okay, so gate can only be the input. It cannot be the output, right? So that is what Sai Kiran was trying to say, and I'm also trying to say the same thing. So it means that Y cannot be an output, rather Y will be an input, right? So this circuit is logically wrong if anybody says that, okay, what will be the expression of Y? the circuit is wrong. And then, but if I say that what will be the expression of A, then Y will be an input and A will be an output, and we can have some expression there. Okay, so A can be an output. Okay, and let's see, if you provide Y equal to 0, right? So this will be on, this will be off. You will get some logic which will be near to 0. Okay, so if you will provide 0 over here, right, you will get 0, right? And if you will provide 1 over here, right, so this will be on, this will be off. Okay, and you will get 1 over here, right? So in the digital logic, right, this will be not a complete one like a full VDD, right? So there will be some drop which is known as threshold voltage drop. You will learn this in the analog electronics or in electronic devices. Okay, and or in the transmission gate, if you have learned, right, so there is always a VT drop, right? If you are connecting VDD to an NMOS gate or ground to a PMOS gate. Okay, so but still it will act as a what we call as a buffer, right? Whatever input you are getting the same output, right? But a very not a very good buffer. Okay, not a very good buffer. So but the catch is Y is input here and A is an output. You cannot have A as input and Y as an output, right? So that is the reason why this circuit was extremely important to understand the concept of the MOS or CMOS logic, right? Whenever you design a CMOS logic, please note that you have to drive, or you have to provide the voltage at the gate of the NMOS or PMOS, okay? And you have to take the output from either source or drain, okay? So this is clear. The final is the answer. It is perfectly correct logic. You provide 0 here, right? This will be on, this will be off. The output will be full VDD, right? VDD is nothing but 1, right? You provide 1 here, this will be off, this will be on. This circuit will be, NMOS will be on, and you will get 0 here. So 0. So for 0, you will get 1. For 1, you will get 0, right? And the answer is this, the fourth circuit, that is an NOT gate, right? So it is good to know that, okay, which is the correct answer, but it is also very important to know that why other answers are incorrect. Okay, and that is the reason why I have explained each of this individual circuit and taken time, so such that you should understand the concept behind the CMOS logic and how you design a circuit using CMOS logic, right? You cannot design it arbitrarily, right? You have to follow certain convention. Okay, so this is the last question for today's session. Everybody is clear on that?
Yes, sir.
Yes, sir.
Yes, sir.
I hope you now have some idea about CMOS, because you have one question from the CMOS circuit in your assignment. Now you try out all your assignments and all, right? And please note, I hope you all have the YouTube link. Okay, you have, right?
No, sir.
You don't have.
No, I don't know. I mean,
Okay,
I don't know about link.
okay, okay. So let me conclude the session, and yeah, please don't leave. I will share the YouTube link with you guys. Okay. So thank you for joining. I'm just stopping the recording.